Good morning, children. In today's class, we are learning a new concept called continuity. A continuous function, f of x. Look at these curves. There is no break at all. The curve goes on and on. Look at this curve and this curve. So these are the curves. Without any break, they are going on and on. Such curves we call continuous. But look at this. There is a break. It is going like this, it is coming like this way, but here there is a break. It is not touching. Similarly, look at this curve. It is coming like this and it is going like this. Here there is a break. So there are points where the curves are not continuous. Look at this curve. So it goes on and on, but at this point there is a break. So such curves we call discontinuous. Now is the question, how to check whether the given function is continuous or not? We have the condition f of a exists. What do you mean by f of a? Suppose I give you f of x equal to x square plus 2. If I want f of a, wherever x comes, put a. So this we call f of a. Just put x as a. Call it as function value, as we did in the first exercise. Second condition. Limit x tends to a, f of x exists. Limit. We have to check whether left limit is there, also right limit is there. So for left limit, put x is equal to a minus h and take h tends to 0. For right limit, put x is equal to a plus h and take h tends to 0. Suppose left and right limits are equal. Declare limit exists. So first condition, function value should exist. Second condition, limit value should exist. And thirdly, both must be equal. So in short, I can say f of x is continuous at x is equal to a if limit x tends to a, f of x equals to f of a. Any one fails also, we will immediately declare it is not continuous. Suppose you are given a function like this, x by x plus 2. Just by looking at this function, I will say not continuous when the denominator is 0. So what is the denominator? X plus 2. So x is equal to minus 2. The function is not continuous. At the point x equals minus 2, the function is not continuous. So objective type questions, we need to find where the function is not continuous. One such idea is put the denominator 0. When and all the denominator is 0, the function is not continuous at that particular point. Now we have some properties. If f of x and g of x are continuous at x is equal to a, then if I add, it is continuous. If I multiply, it is continuous. If I multiply by a number, a scalar, which is a real number, then also it is continuous. So f of x and g of x are continuous at x is equal to a. Adding the two functions or multiplying the two functions or multiplying the function by a scalar, say 2, 3, 4, like that. All these cases I will declare to be continuous at the point x is equal to a. Now, when I have quotient model 1 by f of x or f of x by g of x, what should I remember? the denominator should not become 0. My question is at x is equal to a. So f of a is not 0, then 1 by f of x is also continuous. Similarly, f of x by g of x is continuous if g of a, the denominator, should not become 0 at the point a. So every time in continuity, remember the denominator is not 0 in that particular point. Finally, we say modulus of f of x is also continuous at x is equal to a. Certain functions are everywhere continuous. For example, constant function. How do you define? F of x equal to k. 2, 3, half, 1, anything. So such functions are everywhere continuous. Identity function. We say x goes to x. 1, 1, 2, 2, 3, 3, 4, 4. Like that I plot. It is a continuous function. Polynomial function. Something like ax cube, bx squared, cx plus d. So f of x, there is no denominator. Notice, in all the cases, no denominator. So problem arises mainly when denominators come. In all these cases, we say everywhere continuous. That is continuous in the real number system. Modulus function, say mod x. This is also continuous. Remember the idea? Mod function 1, 1, 2, 2, 3, 3 and minus 1, 1, minus 2, 2, minus 2. So the line goes like this. So this mod x function is also continuous. When we come up to exponential function, x comes in the power. We call exponential and it is also everywhere continuous provided a is a positive quantity. Logarithmic function, when we define, it is continuous in the domain defined in the question. Similarly, rational function. Rational tells me f of x by g of x. Here also the domain will be mentioned. Remember, denominator should not become 0. So rational function is continuous at every point in the domain given. So these are some major ideas to remember. Now we'll proceed on to exercise problems wherein we will check left limit, right limit and limit value, function value. If it is equal, declare to be continuous. If not, discontinuous. Exercise 5.3, question number 1. Examine the following for continuity at the indicated points. F of x equals x square minus 4 by x minus 2 if x is not equal to 2. 0 if x is equal to 2 at x is equal to 2. So we need to find at x is equal to 2. First we'll find out L of f of x. What does this mean? Left limit. The word L f of x implies left limit at the point x is equal to 2. What should I do? Wherever x is coming, put 2 minus h. Limit h tends to 0. So limit h tends to 0 in the function x squared. So I will write 2 minus h the whole square minus 4 by 2 minus h minus 2. Simplifying, limit h tends to 0. Expanded a minus b the whole square. A square plus b square minus 2ab. 2 into h, 4h minus 4 divided by 2 cancels. We are left with minus h. 4 and 4 cancels. In these two terms, h is common. Into h minus 4 divided by minus h. Put limit h tends to 0. H and H gets cancelled. Minus is in the denominator. H tends to 0. 0 minus 4 by minus 1, or my answer is plus 4. In the same way, let us find out right limit. The same idea, but now R of f of x. What does it mean? R stands for right limit at x is equal to 2. Now what should I put? X is equal to 2 plus h, limit h tends to 0. Now in the question, limit h tends to 0. Wherever x is coming, 2 plus h. 2 plus h the whole square minus 4 by 2 plus h minus 2. Limit h tends to 0. Expand it. It is a plus b the whole square. A square plus b square plus 2ab minus 4 divided by 2 cancels h. 4 and 4 cancels. In the numerator, h is common and I am left with h plus 4. H and h will get cancelled. As I put 0, I get 0 plus 4, that is 4. Once I know the right limit and left limit, check whether they are equal. So left limit and right limit are equal to 4. The next idea, function value. So this implies limit exists. Whenever left and right limits are equal, say that the limit exists. Function value. Wherever x is coming, put 2. If x is equal to 2, what is mentioned here? 0. So f of 2 equal to 0. Are they equal? No. So limit value is not equal to function value. So what will you conclude? Therefore, f of x is not continuous. Even though limit exists, it is not continuous at x is equal to 2, and that's the answer. B part, f of x equals x square minus 9 by x minus 3 if x is not equal to 3. 6 if x is equal to 3. So this tells me at x is equal to 3, function value is 6. Let us find out the left and right limits. For left limit, what is the formula? L f of x. Limit h tends to 0. Wherever x is coming, put 3 minus h. I want at x is equal to 3. So, in the place of x, 3 minus h the whole square minus 9 by 3 minus h minus 3. The next step, expand it. It is a minus b the whole square. A square plus b square minus 2 into 3 into h, 6h minus 9 divided by 3 and 3 cancels. We are left with minus h. 9 and 9 cancels. In the numerator, h is common. Taking it out, we have h minus 6 by minus h. H and h gets cancelled. Wherever h is coming, put 0. 0 minus 6 by minus 1, or I get 6. The next step, find out the right limit. How do we write it? R f of x at the point x is equal to 3. Limit h tends to 0. Wherever x is coming, put 3 plus h. 3 plus h the whole square minus 9 by 3 plus h minus 3. 3 cancels. Expand it. Limit h tends to 0. 3 square plus h square plus 2 into 3 into h, 6h. A square plus b square plus 2ab minus 9 divided by h. 9 and 9 cancels. In these two terms, I can take h as common into h plus 6 by h. H and h gets cancelled. Put h tends to 0 plus 6. My answer is 6. Already we have found out function value to be 6. Now, left limit equals to right limit equals to function value equals to 6. All are equal. So left limit at x equal to 3, right limit at x equal to 3 and function value at x equal to 3. All are equal implies f of x is continuous. Hence, left limit and right limit are equal tells us limit exists. F of 3 is given to be 6 in the question. Now all are equal tells me f of x is continuous at x is equal to 3. Question number 2. Show that f of x equals mod x is continuous at x is equal to 0. Left limit, wherever x is coming, we have to put 0, we will need to check. So wherever x is coming, 0 minus h, limit h tends to 0. So L of f of x at the point x equal to 0, limit h tends to 0, modulus of 0 minus h. 0 minus h is minus h only. Modulus of minus h is plus h. Remember, in modulus, even if you put minus h, it becomes positive. So h tends to 0 tells me my answer is 0. Right limit. So what should you do now? Put x is equal to 0 plus h, limit h tends to 0. R of f of x at the point x is equal to 0, limit h tends to 0. In the function modulus, in the place of x put 0 plus h. When I put h tends to 0, 0 plus 0 is 0 only. Now we got L of f of x, R of f of x, both are equal to 0, implies limit exists. What is function value? To find function value, in the place of x, put 0. F of x equals to modulus of 0, that is 0. So all are equal. L, or I can say limit value equals function value. Therefore, f of x is continuous at x is equal to 0.